everyone, welcome back to my channel EduVibe. In today's lesson, we are moving to the next topic of electromagnetic radiations, which is a quantum effect. So this is another effect which is also talking about the is the light is a particle or a wave. So that whole topic we do, and the next topic we do the wave particle durability. In from that topic, we'll come to know that the light is a particle or a wave, or both. So in the last topic, which is light overview, we will going to know about that how the particle, what is the light and how is like particle or wave. So we left only three topics, and then we have to end with the unit. So so today's topic is a quantum effect. So this is important thing, and we integrate this topic into by the momentum. So in the next topic, we do the momentum also, which is a photon momentum. So that topic is little the momentum topic which you do in the first unit, and this topic is also like something intro of that photon momentum. So let's start with this. That how can it be discovered? So in 1923, the American physicist Quantum has able to provide even more evidence for the photon particle model or the photon model, for which he awarded the Nobel Prize in Physics in 1927. Quantum examined the way in which the electrons rattled S rays. So they tell that the electrons can scattle the S-ray rays in a block of graphite. It was observed that S-rays are scattered all the directions. However, this results were obvious and easily explained by both the particle and the wave models of light. So what this experiment they do the electron scattered S-ray light experiment in the block of a graphite, which the obvious thing that they S-rays are scattered in all directions, and they both can be like explained by the particle and the wave models of light. Then they go into the quantum effect more, that how this can be occur. In fact, the results of quantums were defined the wave model in the two ways. So they defined the wave model first in the two ways, that the refraction should not be observed as the angle of incidence is 0 degrees. So there's that the angle of incidence about 0 degrees. However, we see the path of S-ray has changed upon the pass through the fall. So this whole talking about the experiment, do not know about the experiment for now, because you got that. So you have just know about this, not in the examination you get the questions from there. Frequency should not change it directly by the source. However, we see that the wavelength was increased after the S-ray was passed through the foil, decreasing its frequency. In that thing, they directed by the when they directed the source in this will increase the wavelength, and will after the S-ray was passed through the foil and decreasing frequency. So this quantum effect will do that things, and after the end, they're doing some cosmic acids. So after the end, they will tell us that what is quantum effect, the change in wavelength. So the change in wavelength, as you can say, that wavelength is increases. So change in wavelength of the scattered S-ray photon is known as the photon effect, also called the quantum scattering, because there is some scattering part. So we also come to know about in the wavelengths part, that wavelength initially and wavelength after scattered. So this formula we have also we discussed too. The quantum effect consequently is also laws of the conservation of energy and the momentum. And interaction between the S-ray photon and the electron must obey these two laws. When you're doing the S-ray photon and the electron thing, interaction between the both, so they obey these two rules, that the conservation of energy and momentum, which are very important from that experiment they do. The key result for quantum effect is that demonstrate the photons have momentum. So when they demonstrate the photons, they will that the result that they have the momentum too. From here, they come to know about what is the photon momentum. We will learn more about photon momentum in the next lesson. Contributes more to the idea that while the light have the wave characteristics, it can also have the particle characteristics. A movement is the characteristic we generally associate with the particles. Okay, after they tell us that the idea that the light has the wave characteristics too, and the light has the particle characteristics too. They tell that with the quantum effect that the light has the wave particle light behavior as a wave too, and a particle too. The two co-sequences, they will tell that the total momentum of the incident S-ray must be equal to the total momentum of the scattered S-ray momentum and the spectral momentum conservation of momentum. For conservation of energy, they will tell the total energy of the incident S-ray photon and the load electron must equal to the total energy of the scattered S-ray photon. So they tell the incident S-ray and the scattered S-ray momentums are equal, their energies are equal with that two laws. From here we come to another light behave as a wave and the particle both. And they will do that photon momentum too. We have the formula for photon momentum in the next lesson we discussed. For now, we have just know about that. They will get to know about the photon momentum. They will discover that thing. And we have the quantum equation. The delta, because we all do with the wavelengths. So delta wavelength is equal to h upon mc, which is the mass and the speed of light, this thing. And the mass of the subatomic particle, usually electron. And we have 1 minus cos theta. Cos theta is the scattering angle. When they do the scatter thing with anything shown on the metal or any surface, they made some angle. So that's why we have an angle. H is a Planck's constant, and this is the wavelength, change in wavelength. And also the change in wavelength is equal to the scattered photon in meters, which is minus with by incoming photon, which is the incident photon. So that formula, that quantum formula, delta wavelength formula we have, but that formula is not on your formula sheet. You have to know this. So this is an easy thing. You have to know this because we use a number of times when we do the questions. So that two formulas you have to know, and that thing all are same, and we use it in the questions. So let's do straight to the example of this. The stationary electron is touched by an S-ray photon. After the collision, the photon scatters with an angle of 35.4 degrees. Wavelength of 3.25 10 raised to minus 12 meters. Determine the initial wavelength of the photon. So we have to find the initial wavelength. So after scatter, we have the wavelength. So we have a wavelength S. We have to find the wavelength I. But firstly, we have to find the delta wavelength. For delta wavelength, we have the formula m upon mc 1 minus cos theta. What h you have to do? Joules. 6.63 into 10 raised to power minus 34 joules per second. Mass you have taken for the electron, 9.11 10 raised to minus 31 kgs. C 3.0 10 raised to power 8 meter per second. And we have a 1 minus cos 35.4 degrees. Make sure you're in a degree mode when you solve this angle. You get 4.484 into 10 raised to power minus 13 meters. When you get this, so you know delta wavelength is equal to the wavelength of scatter minus wavelength of the incident. So this is equal to the, so the wavelength I is equal to the wavelength of x minus delta wavelength. So this is equal to the 3.25 10 raised to power minus 12 meters minus this by 4.484 into 10 raised to power minus 13 meters. This whole thing is equal to, when you solve this, you get 2.80 10 raised to power minus 12 meters. So this is your incident wavelength, which is the initial wavelength of the photon. That's how you can solve the questions. But this is like a simple question you get. You get the complex questions like this. And you'll find something else with doing something else. Okay. The S-ray frequency of 4.50 into 10 raised to 20 Hz, you have a frequency now. Undergoes a quantum scattering and result in a frequency of this. We have a first frequency, which is frequency I, you can say. And you have a second frequency, which after scattered is this 4.20. So this is like the scattering frequency. Determine the scattering angle of the S-ray. So we have to find the theta. But you don't have any wavelength thing. You can find the delta wavelength. So for now you can find, you have to find the angle. So from here I can make that equation for that. 1 minus cos theta. This is equal to the mc delta wavelength upon h. 1 minus cos theta. Now the cos theta is equal to 1 minus mc delta wavelength upon h. This is equal to cos minus 1, which is 1 minus mc delta wavelength upon h. You have all the things, like you have 1 minus mass of electron, you have c, but you don't have the delta wavelength. You also have the H, which is 6.63 into 10 raised to power minus 34 joules per second. You can find this delta wavelength with that information of frequency. So basically, delta wavelength is equal to wavelength of stratal minus wavelength of the initial wavelength. So that two things are equal to each other. You have to know the wavelength formula. So C is equal to frequency times wavelength. So wavelength is equal to the C upon frequency. So C remains the same for this frequency. You can take for the S, which is scattered, minus you can take this for the I. You can put the things down. So C is 3.0 10 raised to power 8 meter per second. The stratal one is 4.20 10 raised to power 20 hertz. This should be minus with again 3.00 10 raised to power 8 meter per second. Divide this by 4.50 10 raised to power 20 hertz. You have that things too. You can find it like that. You solve this, you get the delta wavelength of 4.7619 into 10 raised to power minus 14 meters. Put this thing over there now. So 4.7619 into 10 raised to power minus 14 meters. So you can solve this, make sure in the degree mode. No, like you have to do the the inverse of cos. So you get 11.371 something, which is 11.4 degrees. And this is your answer. You find the starting angle of the aspect. So that's how you can deal with something you get like this. Something you get the frequencies, you solve like this and get your answer whichever one they want. Sometimes you get you in that question you always have electron, so you have to know about the mass of the electron, which is in a formula sheet. So don't worry about this. So that's all for this lesson. And next lesson we're testing about the photon momentum more. This is like an intro for the photon magnitude. So that's all for this lesson. Anyways, if we EduVibe, learn smarter, not harder. Please like, share, and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till us, you get it with EduVibe.